Hello friends, I welcome all of you to my new tutorial video on frequency analysis by Mike EVA. Mike EVA is a module of Mike 0. EVA stands for Extreme Value Analysis. So let's get started for the tutorial. Mm, And this is a data set of a station named Baruria Station in Podda River. Uh, and we have discharge data and water level data as we see in the time series file, and there is a DFSO file, and I have already made a tutorial on how to make a DFSO file. You can see my previous video. So in this data set, we will first copy this data and I will paste into an Excel file, and then by pivot table method we'll select the maximum water level. Actually we will do the frequency analysis for water level, so we'll just take the column of water level column which is extreme right side, which is in extreme right side as you see, which is marked as yellow color. So by pivot table, by the existence of pivot table in the Excel, we will find out the maximum water level for each year, like this. See, I have already now done an analysis of this time series by pivot table, and I got the maximum water level for each year from 1965 to 2018, and I have a continuous maximum water level for each year from 1965 to 2018. If your data set is big enough or large large enough, I mean the period is larger, your frequency analysis will be good. Like if you want to predict in 100-year return period, you must have uh, more than 50-year data, or more than 50 is it's okay to predict a 100-year return period water level. So it's better to predict a 100-year return period if you have a 100-year uh, data set. So most of the cases there is limitation of data. So for 100-year prediction, more than 50-year data is quite good. So for each year I got an water level, which is maximum water level. Actually, I need the maximum water level. So for design, so I have chosen maximum water level by the help of a pivot table in the Excel. As for each year, see, I have to make it in date format so that I can prepare a DFSO file, which is a time series. So I have to add a month or date. So I just added July month and the 1st January for each data, but my year is okay, but the time and the month and the day is not okay. If you want to get correct date corresponding to the maximum water level, you can get it, no problem. But if you just write it this way, just keeping the um, year right, but it will work perfectly, no problem. So I have already prepared a time series. Let me show you the time series. I have prepared this yearly maximum water level time series. Now I got this plot after preparing the DFSO file. See, from 1965 to 2018, I have the dataset, 53 dataset, more than 50. So it's quite good dataset I have. We'll do it by AMS method. There are two methods actually in frequency analysis by Mike EVA. One is AMS and another one is PDS. So if we have continuous data, say we have data in each year, then we can implement AMS method in the Mike EVA. So I have prepared this DFSO file from the maximum water level for each year. Now this is our Mic EVA interface of Mic 0. The left panel, navigation panel, you will see the setup file. Setup. Just expand it and set here input data file. Here you set the Baruria water level, maximum water level that you prepared the DFSO file for maximum water level in each year. Just select it, and you, after giving input that DFSO file, you will extract here. A pop out will be appeared in the screen. You have to save this file before you extract the file into the AMS. Before doing that, your output file should be like this. One is your main file, another one you will prepare for the analysis. Just give another name. Let's say I just put a suffix like AMS. Save. Yes, then you have to click on extract. Yes, the extraction of extreme value series completed, and click on OK. Selection method, click on AMS. I will show the PDS method. PDS method is applied if there is discontinuity. Suppose you have a data of 1965, then 1960, 1966 or 1970 is missing. You have 1971. Then we will go for PDS method. You can set the title, subtitle, and input data file. In here, input data file is the AMS file that has created by extraction. You will show that DFSO file here, and you have to set a EVA result file. Just I have already done this analysis. Done this analysis, so you have to write a result file name and click on save. Yes. Now we know there are several distribution systems like Gumbel, log normal, log Pearson type 3, and there's so many more distribution. And which distribution is you will use, that depends on you. Or actually you will select the distribution which I-square value is is less than other distribution. I have selected 3 distribution: Gumbel, log normal, and log Pearson type 3. You can add more distribution. These distributions are available in the Mic EVA. Now, if you click on analysis, goodness of fit statistics, which goodness of fit you want. There are several kind of goodness of fit. If you want to check chi-square test or Kolmogorov Smirnov test, you just check it, and you will see after analysis the minimum value and take that value for your analysis, for your further analysis. And for which return period you want to get the data. That's the important thing. Suppose you want to project 1 in 100-year return period water level. You want to know the water level which can occur in next after 100 years or after 25 years, what it could be. According to design criteria, you have to set the periods. If you want to set another return period like 70, then you just click here and hit on the insert button of keyboard. So right here 70, okay, 80. Uncertainty calculations, click on Monte Carlo. Okay, then finally you have to click on run. Computation completed successfully. So your result is okay. Now click on output. There are several kind of output. If you want to see the plot, click on plot. This is the frequency plot. This is the probability plot. So I need the probability plot actually. So if you want to only gamble, then click on properties. I just want to see the gamble. Okay, this is my gamble distribution. If you want to save this map, save this plot, just save to right click on the mouse and save to bitmap. You can save as JPG or PNG, whatever. Again, if you want to log normal, export log normal distribution plot, then which here, then you can save like this. Your output path will be here, and the format you can set from here. Or you can also get the table, and the table is right here. See which value we will take. There is estimated quantile. See, there is in the return period year, return period column, which is 10-year return period, 25, 50, 70, 100. So in 100-year return period, the water level for is 9.9 in Gamble distribution, and 9.8 is log Pearson type 3 distribution. So the goodness of fit, if we check the chi-square test, the minimum value is 7.48, which is for Gamble, and we can take consider the Gamble distribution for 100-year return period, which is 9.9, and for any design purpose or any other purpose, we can use this 9.9 value, or for our reporting, we can just copy this table into the report, and we can easily do the frequency analysis by mic EVA, which is a very powerful tool of mic 0. Thank you so much for watching this video. Please subscribe my channel for a new tutorial, and I will continue to update channel with new tutorials.